Classwork Solutions, May 27th, number 2. We have f of x, which is another way of saying the output y, is equal to 3x squared plus 6x minus 1. Recognize that a is 3, since it's the coefficient of x squared. B is equal to 6, since it's the coefficient of x to the first, and the constant is negative 1. You would like to first find out what the axis of symmetry would be, and the equation can be found by using the formula x equals negative b over 2a. In this case, this is going to be a negative 6 over 2 times 3. Negative 6 over 6, negative 1 is your x value. And that would also be the axis of symmetry equation, but also the x value of the vertex. In order to find the y value of the vertex, we're going to plug in that x value into the equation. 3 times negative 1 for x, square that, plus 6 times negative 1 for x, minus 1. And this is going to be 3 times 1, negative 1 squared is 1, minus 6 minus 1. 3 minus 6 minus 1, 3 minus 6 is negative 3, minus 1 is negative 4. Therefore, your vertex is negative 1 comma negative 4. We're going to reserve 3 rows, and then we're going to put the vertex in that 4th row. And the computations that go along with it would be placed in the middle box here. Then we want to choose our x values carefully. We want to show 3 of them that are below that x value and 3 that are above. So I'm going to use negative 2, negative 3, and negative 4, and I'm going to use 0, 1, and 2. And I'm going to plug those x values into that equation. 3 times negative 4 squared plus 6 times negative 4 minus 1. In the next row, we're going to use x is negative 3. 3 times negative 3 squared plus 6 times negative 3 minus 1. Next, x is negative 2. 3 times negative 2 squared plus 6 times negative 2 minus 1. We already have that vertex row figured out. The next row would be 0 is x. 3 times 0 squared plus 6 times 0 minus 1. Next row, x is 1. 3 times 1 squared plus 6 times 1 minus 1. And then you have x is 2. So 3 times 2 squared plus 6 times 2 minus 1. We're going to use our calculator to help us. First, go to and plug the equation in. Y equals 3x squared plus 6x minus 1. And then go ahead and look at the graph. In this case, our window is appropriate. If not, we would have to have adjusted it. Go to second graph and find the table. I want to go up and see that x is negative 4, y is 23. When x is negative 3, y is 8. When x is negative 2, y is negative 1. I'm pulling all these from this table on the graphing calculator. When x is negative 1, y is negative 4. We knew that already from our vertex. When 0 is x is 0, y is negative 1. When x is 1, y is 8. When x is 2, y is back to 23. And if you have chosen your x values carefully, you will notice that there is symmetry in the output values. And we're going to graph this. Set up your grid. And with this case, it's going to be difficult with the grid here to graph when y is 23. So we're not going to graph that particular point, but we will do the other ones. Now after our grid is set up, and we already have labels on the x-axis and the y-axis, we can go ahead and plot the points from the table. Negative 4, 23, we're not going to graph that. Negative 3, 8, negative 3, 8, negative 2, 1. I'm sorry, negative 2, negative 1. So that's not the point. Negative 2, negative 1 would be here. This point I'm going to neglect. I put an X through it. Negative 1, negative 4, which is your vertex. I'll put a V there for vertex. 0, 1, negative 1, which is a y-intercept. Negative, and then next is 1, 8. And again, we're not going to graph 2, 23 because that y value would not fit into the grid. We're going to connect these with a smooth curve. And what you'll notice is that when you compare what we had for the graph of number 1, the graph for number 2 seems narrower, and it is narrower, because the equation would influence how stretched out the graph is or how shrinked or narrow it is.